Hey guys, here we are looking at 04.03 and some of the example problems that go along with it. I'm not going to be going through all 9 pages, but just like the last video, I'm going to try to focus on some of those examples that'll hopefully help you when you're taking your quiz. Here we are on page 2, looking at the bottom part talking about using exponential properties. We have an example there at the bottom that I want to make sure I go through. Here's our example. 3 times 4 to the power of 3x. Something that we learned from our last lesson is that when you have two numbers being multiplied together, for example, my 3 to the power of x, that can also be written as 4 to the third to the power of x. The reason being is because when I'm raising a power to another power, I multiply them together. So I can also do the opposite and split them back up. So what I'm going to do here is I'm going to do exactly that. I'm going to take 4 to the third on the inside of the parentheses. As I evaluate that and do 4 to the third power, which is going to be 4 times 4, which is 16 times 4 is 64 to the power of x. Now, some of you might think that you should go ahead and multiply the 64 and the 3 together, and you cannot do that. Remember, you do have an order of operations, which is PEMDAS. Anything on the inside of the parentheses first, well, it's just 64, so I can't really do anything, so that's done. Then you must do the exponent. Since the exponent is not a number, I can't actually calculate that, so it stops there. I cannot multiply, divide, add, or subtract any further because my variable is the exponent. So my final answer will be 3 times 64 to the power of x. Now on page 5, we talk about a concept called average rate of change. So not necessarily your typical constant rate of change, which happens in linear functions, but we want average rate of change. So example 1, it says you start out with a penny that will double every day for 30 days. Find the average rate of change from day 7 to day 14. Remember, this is the function, so this is the equation that we're using. All right, guys, so here we've got the setup for example number 1. So we're using the same exact equation that the problem gives us, but we're trying to find the amounts for 2 different types of days. First, we've got where we have 7 days. So we're starting from 7 days, and we're going to 14 days. Okay, so I need to solve this twice in order to see what those two values are, and then we can find the average rate of change. So I'm going to take 0.01 times 2 to the power of 7. Please, please, please remember your order of operations. So you do not want to multiply first, but you want to do the exponent first. So we're going to take 2 to the power of 7. I'm going to set this side up real quick. So I have 0.01 and then times 2 to the power of 14. So I'm going to do the same thing on this side. And I'm going to leave a blank spot there. So what we get here, and I'm going to use my calculator, is 128 for 2 to the power of 7. And then on the other side, actually I had to change that to make it a bigger space, I have 16,384 if I do that in the calculator. Now I want to take those two numbers and multiply them by 0.01. So on the left side for 7 days, I get 1.28. And then on the right side for 14 days, I get 163.84. Okay, so after 7 days, I'm going to have, it looks like $1.28. And then after 14 days, I'm going to have $168.84. Now that I have those two values, I'm going to go ahead and find the average rate of change. I want to take the amount that I got for the largest amount of days, so 14 days, and I'm going to subtract it by the amount for the lowest number of days. I'm going to divide that by the largest amount of days minus the lowest amount of days. So I have my highest amount, my lowest amount, subtracting them together. I have my highest day and my lowest day, subtracting them together. 163.84 minus 1.28 is 162.56. And 14 minus 7 is 7. As I go ahead and divide that, the average change that I get is 23. $23.22. So it looks like between those 7 days, it's an average increase of $23.22 per day. All right, guys, so here's our very first activity on page 6 that we want to go ahead and complete and see what we get. So what it says here is that we want to say which is equivalent. So based on kind of the example that you already saw, and this is going to be hard since I'm using my mouse, but we do what we can. Following the same process that we did before, when I have a number on the outside, I can easily transfer that to the inside of my parentheses through the power rule. So instead of the 2 to the power, or 2x being on the outside, I can make that 2 come to the inside. Now the 5 is going to remain on the outside. I cannot change that, but 3 to the power of 2 is 9. And then all I'm left with as an exponent is going to be x. I cannot, absolutely cannot multiply 5 times 9 due to PEMDAS, so it must stay like that. And let's go ahead and click my answer and submit. That looks great. Sweet. Let's go next. All right, guys, so here we go, question number 2. I prematurely clicked the correct answer, but it's all right. The 3 must stay in front. The number in front does not change ever. The only thing I'm going to do is I'm going to take this 5 that's on the exponent and I'm going to transfer it to the inside. So I'm going to take 1.2 to the power of 5. After we calculate 1.2 times 1.2 times 1.2 times 1.2 times 1.2, we end up with 2.488. So our answer is B. Let's check it. Awesome. All right, guys, so question number 3. This one, kind of a step up, but same concept. The 4 all the way in the front does not change. Nothing happens to that. So as you can see, all of my answer choices have a 4 in front, so that doesn't really help this time. But you will notice that I have 1 plus 0.07 on the inside of my parentheses. So that is something that I have to calculate first. Remember, parentheses are your very first operation in your order of operations. So just a little recap, we have parentheses, exponents, multiplication, division, addition, subtraction. So I want to go ahead and add that together first. So 1.7, and then I want to raise it to the power of 3. Oh gosh, that's kind of difficult. Let me try that again. 1.7 to the power of 3. After you calculate 1.7 to the power of 3, you do get 4.913, etc. So here's my answer here. Let me go ahead and submit. And we got that one correct again. All right, guys, looking at number 4. Number 4, so same exact concept. I'm going to take inside the parentheses first. So 1 plus negative 0.03, nothing changes. You still do the same thing. So you could also do 1 minus 0.03, okay? Raised to the power of 7. So raised to the power of 7. In my calculator, I got 0.8079, etc. Keep in mind the number in front should match your answer. So 1.2 should be 1.2, looking good to me. And we got it. All right, and last one, number 5. Oh, that was it, 4 out of 4. Sweet. All right, guys, here we are on page 7 with just a couple more practice problems. So it says the average price of a car is $30,000. Each year, the value of the car decreases by 15%. So before I read the question, I'm going to analyze kind of what's going on here. I have just numbers like 1, 2, 3, 4. I'm going to assume that that's going to be the years. Also, if you remember what I said in class, 99.9% of the time, the x-axis on the bottom is going to be time. So that's going to be year. And it looks like this is going to be money going up the y-axis. And it looks like I'm right because if I'm looking at it correctly, 30,000 is where my graph is going to start. And it says the average price for a new car is 30,000. So my question says, explain the meaning of the y-intercept, appropriate domain and range, and whether the function is increasing or decreasing. I'm going to start backwards on this one because the last question is the easiest. This is definitely decreasing. It is going down to the right, so definitely decreasing. So we got that one. Appropriate domain and range. Okay, domain and range. So it looks like my domain is probably going to be positive real numbers, so anything off to the right that is positive. So starting at 0, anything off to the right that is positive. In a real world situation, there's going to be a point at which your car is not really worth anything anymore, but we're going to assume that it's kind of going to go on to all the positive numbers. My range, it looks like it's going to be starting at $30,000 and pretty much down to 0. There's not really a way that your car is going to cost you less than that. And then as we write that, we want to make sure we write it as 0 up to 30,000. And then the meaning of the y-intercept. I would say the y-intercept is how much your car is priced at the beginning before you even buy it, before you drive it off the lot. So let's see what it says. Y-intercept is a starting price. Sweet, we got that. Domain would be all real numbers, where we go from 0 to positive infinity. Sweet. So the positive numbers only, which is what we said. The range would be all real numbers, where we're going from 0 to 30,000, which is what we said. And then it is decreasing. Sweet. And for the last one, we're going to look at number 3. So 3 functions are graphed below. P of x here in green, that is exponential, and the other 2 are linear. Okay, hopefully you see that they're straight lines. Explain which functions have a domain of all real numbers. So ideally, we're looking for which graph hopefully has arrows on it and is going to keep going on forever. Well, I'm going to look at my blue graph. You're going to notice that it kind of goes from -2 to like not even 1, like a quarter, but it doesn't keep going, it stops. So that is definitely not all real numbers. Okay, so let's look at my red. You're going to see that it starts at like -1 maybe, and it goes to 4. But it stops on both ends. It does not have arrows. It does not keep going on forever. So it cannot be that one. It's going to have to be the green one, P of x. Even though there's no arrows, I do know based on the problem that it is exponential, and an exponential function is always all real numbers for the domain. And for question number 2, we've got, again, elimination in rounds. We're going from 1 to 5. So we're going to take a look at this. And for example number 3, it looks like we have a question with a graph. So we're comparing the average rate of change from 0 to 1, and then from 2 to 3. We're going to take a look at that as well. All right, so here's what I've got for example number 2. I'm going to try to do this on the screen. So we have a robotics competition as 5 rounds. Only a third make it, yada yada. Here's my table. So round 1 through 5. Start with 162, and we end with 2 teams at the end. Compute the average rate of change from 1 to 5. So I'm going 5 to 1 on the bottom. And the reason I'm doing that is because I'm increasing in rounds. I'm adding 4 rounds. So if I did 1 minus 5, it would be negative, but I want it to be positive. So I'm going to do 5 minus 1. And then on the 5th round, there's 2 teams left, and on the 1st round, there was 162. So I want to make sure I write those in order. 2 minus 162 is going to be negative 160. 5 minus 1 is 4. Okay, so it looks like there's our average rate of change. I'm going to see if I can divide that, and it looks like I can. I get negative 40. So it looks like the average rate of change is negative 40 teams per round. So let's see what we got if that was correct. It looks like it is negative 40 teams per round. And here we are looking through the graph. The graphs are slightly more involved, so I'm not really going to write them out. But as you can see on the graph here, we're going from 0 to 1. So here's the work for this side. When x is 0, y is 2. And that we know by looking at the point. It says 0, 2. And then this says 1, 6. So what they did is they took 6 minus 2, kind of like if you're finding slope. So 6 minus 2 over 1 minus 0, that would be 4 over 1, which is 4. Okay. And then from 2 to 3. So same process. We have 2, 18, and then 3, 54. So I'm going to do the 54 minus 18, so subtract the y's. And then I'm going to do 3 minus 2, subtract the x's. I get 36 over 1, which is an average rate of change of 36. Last but not least, we have page 9, which is reviewing some of the formulas and key concepts. I hope working some of this out really helped you guys in looking through your test. If you need anything, if you need any more help, just let me know. and I'll be more than happy to help you out. Good luck.